Good afternoon, everyone. Welcome to the Norman Foster Foundation public debate on robotics. Welcome to those of you here in the room in Madrid, and to those of you watching online as well. You're all very welcome. I'm Tim Stoner. I'm your host for the event today, and I will be chairing a debate among 6 excellent speakers, as well as opening up to you for questions and answer in the course of our event. We're going to be doing this in 2 halves. We'll have short presentations first from 3 of our speakers. Then we'll have 15 or so minutes of conversation between them. You'll find, I hope, that they don't agree on everything, and that will give us something to think through. I'll then try, if they let me, to open up to you to ask questions of them. We'll then repeat that formula. We'll replicate it in the second half of the event. So if you don't get the chance to ask your question in the first half, hold it for the second and try to catch my eye. Let me take this opportunity to thank the Rolex Institute for their support both for today's public debate, indeed their support over the last 3 years for the robotics debates and the week-long ateliers that are being held, including this week's, at the Norman Foster Foundation. These ateliers bring together a talented and international group of scholars to think through and make designs about the subject of robotics. The scholars are being mentored by Xavier de Kestelier. Xavier is the first of today's speaker. He's a principal at HASSELL Architects, and he's taught widely on the subjects of computation and robotics. So let us welcome him to the stage as our first speaker. Xavier.
Thank you. First, I'm going to do a small intro to the workshop and the atelier that we've been running here with the students, with the 10 amazing students. So today really started for me 10 years ago. I was fortunate enough to be involved in the first large-scale 3D concrete printing project at Foster & Partners. That was the first time we took printers and we scaled them up and were able to start thinking about objects that are larger than the bits that you kind of get from the normal desktop printers. It was very hard. It was very challenging to get this done for many, many reasons. And now, all these years later, 10 years later, I don't find these 3D printers on construction sites. They're not there yet. So what happened? And I haven't given up yet. So I thought, when I was asked to do the atelier, I thought this is an exact great challenge to see if we can solve it. Now, at that point, I was working with Manuel, who will speak later, at a project for a design museum. And he was designing some furniture, as you see. And it's actually right here, next to me, on the stage. And this furniture is 3D printed by robotics. And when I looked at this, and he showed me that, I'm going to do something now, that he actually prints this like this. I thought, well, that is about the size of a cladding panel of a building. So maybe we can start thinking about buildings again and 3D printing. Now, that is where it will be printed. The models that the students will be designing, the facade cladding panels that will be designed by the scholars at Nagami factory, about an hour away from here. And just before the presentation, I got a little slide already from the first part that we've been printing. That was last night. So through the whole week, we will be printing more and designing more and testing more and more. So, now do my keynote straight away. You saw the big robotic printer at Nagami. Well, this is the grandfather or the grandmother of that robotic arm. This is the first robotic arm, the Unimate, being used in General Motors, in manufacturing. Now, back then, this is 1961, people got really excited about robotics, so they thought, well, what else can we do with it? What else is possible? Let's watch a small video.
Just imagine the scene when Mr. and Mrs. 2000 sit down to breakfast with their very own automatic au pair, which makes the pop-up toaster seem primeval. And while Mr. 2000 goes off to his work, naturally he'll be a computer programmer, the missus can settle down to the high life and enjoy watching someone or thing get on with it. It's well worth celebrating. Unimate will do whatever you tell it, and it never forgets. You just have to remember to switch it off or it'll go on raiding the larder all day and night. And that could mean having an automatic one-armed bandit round the house.
I'd like to think a lot of things changed since then, but robots didn't, right? Excuse me. Robots are still in factories making cars, Teslas now. So what about architecture? What about construction? Well, some robots, there are some factories out there that are constructing parts in factories, wall systems. But what about construction sites themselves? Well, we can start bringing these robots to construction sites, but it's not without problems. Do they really belong there? Because if you can see, this is a small robot, Sam, it's called, that can lay bricks down, and it can't do really on its own, because there's a lot of workers around it trying to help it. So maybe that robotic arm on a construction site, on a complex construction site, because these are not like factories, construction sites constantly change, maybe it's not the right thing. So I worked on a project where we started to kind of rethink that robotic device, that robotic arm. This is a project for the Centennial Challenge with NASA, looking at habitats on Mars. Problem with Mars is you get lots of radiation. You need to protect yourself from that, so you construct a shell structure. A shell structure made by robots, a swarm of robots using local material, regolith, Martian dust. Now, this is not one robot, this is a series of robots. We call it a swarm of robots. They're very different. They each have their own task. One digs, one transports it, one brings it. So lots of kind of different tasks happening together. But what we did with that one was we kind of pushed it a little bit further. We started to looking at modular robotics. So it's kind of a Lego system where you might have a one-wheel robot, you might then bring more wheels, you might bring some diggers into it, you start to assemble it into a different system. So you can reuse, recycle, and remake your own robots. And in this little video, you see the robots, kind of the parts magically coming from the sky. In reality, it doesn't go like that. This is kind of more schematic, how the topology of it would work. And just by having one wheel being able to go up and down, it can actually start to attach and make different configurations. And I'm just going to leave with this here. I'm just trying to see, maybe we just come up with a new type of robotics. It's not industrial robotics that we have. It's not swarm robotics, right? The difference is swarm robotics, they're very resilient, right? So you can maybe lose half of it and they still kind of do their task. Industrial robots, they are very good to do a particular task, but when one breaks, the whole sequence breaks. We think we kind of found out something that maybe sits in the middle. We call it modular autonomous robotic swarm. And funny enough, it's spelled Mars as well. Thank you.
Superb. Thank you, Xavier. What a great way to start to get us into today's event. Our next speaker is Adrian Bowyer. Adrian is the inspiration for the founder for something called RepRap, which he'll tell us all about. He's formerly a professor at the University of Bath in the UK. Please join us, Adrian.
Thank you, and hello, everybody. Let's see if I can press the right button on this. No, that was the wrong button. Xavier has already talked about useful things being made by 3D printers. A little while ago, there was an online survey of what people liked the idea of 3D printers making, and the thing that came out top was another 3D printer, 3D printing the components of 3D printers. And that is what the RepRap project was and is about, making 3D printers print more 3D printers. Let me just start with a rather more general idea. It's this one. This is a graph of misfortune at the end, left-hand end there. For most of the history of the human race, human beings have been impoverished. By impoverished, I mean more or less not knowing where the next 2 or 3 meals are coming from. But that started to change around 200 years ago. And if we plot the graph of poverty against time on the bottom axis, as you can see, these data came from the University of Oxford. That should be a little bit to the left. If we plot that graph, we can see that this is a very hopeful graph indeed. At the beginning of the 19th century, the vast majority of the human race were living in poverty. Now 9% of the human race are living in poverty. That's 9% too many, of course, but nonetheless, it's clearly a lot better. And a significant fraction of that progress has been made during the lifetimes of people still alive today. You can see I've put a little marker on there for people born today. Now, what caused that? What caused it was the idea of having machines make machines. We'd had machines for a long time before this. We'd had seagoing sailing ships, we'd had horses and carts, we'd had all the machinery that tools you have in a blacksmith's workshop and so on for many hundreds of years. The thing that happened with the Industrial Revolution is we had the idea of using these machines to make more machines. So we have a lathe, and that lathe makes the bearings for bicycle wheels and so on. So we've got machines making machines. So why not have the machine make itself? Now, this is not my idea. The idea that a machine might copy itself goes right back to a conversation between René Descartes and Queen Christina of Sweden many hundreds of years ago, where Descartes proposed that living things were machines, and Queen Christina indicated a clock on the wall and say, "See to it that brings forth children," intending to disprove Descartes' idea. But now we have a fairly clear understanding of the mechanics of living objects and living beings, and we know that living things do work chemically and mechanically. Here is a picture of the very first 3D printer making another 3D printer. That's me on the left, and on the right is a friend of mine, Vic Oliver from New Zealand. And on the left is the very first machine back on the 29th of May, 11 years ago, which had just finished printing the parts for the machine on the right. And at this point, at 2 o'clock in the afternoon, we'd just had the machine on the right print its first successful grandchild part. And this project is called RepRap, which is short for Replicating Rapid Prototyper. At the time when I started it, 3D printers were called rapid prototypers. It's a self-replicating 3D printer. And there's a picture of, incidentally, a modern RepRap, a descendant of the machine you just saw. Everything in that machine that's red or blue or white was printed in another such machine. And one of the very first decisions I made in this project was to give it all away free. Now, you may imagine that that means I'm uncommonly generous. It's not that at all. It's that I'm uncommonly lazy. The reason I chose to give it all away free was as follows. If you've got a machine that copies itself, and you, for example, try to patent it, what you're saying to the world is, I want to spend the rest of my life in court trying to stop people doing with my machine the one thing it was designed to do, make copies of itself. So I've got better things to do with my time. And the inevitable conclusion from that argument is that you have to open source everything to do with the project, which we did. And a consequence of that is that the project gained considerable publicity in the press, and that brought in volunteers to work on it from all over the world, many of whom I hadn't met and indeed still haven't met. We all communicated electronically, contributed to the design, to the software, to the design of the electronics as well as the mechanics and so on. And as a consequence of this project, most 3D printers made today are now RepRaps, and the price of these machines has fallen considerably. When I started the project, the cheapest 3D printer you could buy cost 40,000 euros. We got that down to 400 euros, a change of a factor of 100 in the price, which is significant. Now, something that the machine cannot do is to make a structure that's bigger than itself. It can make the components of a structure that's bigger than itself, but in order to use those components, if we wish to automate the construction of a large object, we have to have something that's capable of working in a rather different way. And this is not my work, this is some work by Ben Jennett and Neil Gershenfeld at MIT. And what we've got here is a little robot that's walking about on the structure which it's building, and building, as you can see, a structure made of standard parts, and those standard parts can be assembled into a structure that is as big as you like, as long as it's physically strong enough, even though the little robot is really quite small. And of course, as you would expect, the parts that are being assembled have been made in a 3D printer, and the little robot itself is also made in a 3D printer. But the robot does not assemble itself. But I contend that a comparatively small change in the design of that little robot would allow it to be made from the parts that it itself is assembling. So, yes, so we need a machine that will both assemble things and a machine that will print the parts to be assembled. So, what we have now is people have reversed what we call economies of scale, of course. All of you have your own CD pressing plant, your own photographic lab, and your own printing press. They don't look like those traditional versions. They look like your computer. So given that we've taken those industries back to ourselves, why don't we take all industry back to ourselves? If people can do those industrial processes, why shouldn't people have their own factory? And if people are going to have their own factory, let's have it make more factories. Thank you very much indeed. Okay.
Thank you, Adrian. I don't know about you, I could listen to Adrian all day, but I have the worst job in the room of having to get him off stage. To introduce Manuel, who is the last speaker in this session, the founding partner of Nagami, and also a professor at the Bartlett School at University College London.
Hi everyone, thank you for the kind introduction and for the invitation to be here. I worked on this building 10 years ago, and it's the very first time I visited. So it's probably everything is aligned. So this is the world today, right? This is Ocado, and that's Amazon. This is automation. This is why we receive packages the following day. This is why everything becomes more agile. This is why prices go down and everything becomes more global. This is construction today, as it has been for the last, I don't know how many years. It's a wasteful, dangerous, probably not made for humans industry. In fact, and perhaps this is one of the problems, I think if you can spot construction in this graph, is right above agriculture and hunting. Yeah? This is the digitalization in industries, right? So the only industry less automated and less digital than architecture and construction is hunting, because agriculture, I think they are not taking into account everything that is happening in Asia. So you see that also related to the level of productivity in construction today, and the decrease over the last years. On the other hand, we are in a global construction crisis, right? In a global housing crisis, better said. Especially here in Madrid, we probably know it very well. We also know it in the UK. I'm in both places, which is great. So this is how our productivity in making housing is decreasing over the years. And this is how it's affecting the prices of housing. So effectively, perhaps there's a problem with the way we design and build architecture, since things have never changed from the 50s. In fact, modernism was pretty much related to Industrial Revolution. We could fabricate parts over and over and assemble them, and that actually reduced the price of housing. So this was never a luxurious project, but rather a social project. So this introduces a new question: what is the new architecture for the age of automation? And I think there is pretty much a huge contrast here. This is a picture taken around the corner in Madrid. This is how we're dealing with housing in the age of automation while we're fabricating Teslas. So there are actually some companies taking advantage of this, or really thinking about how to apply automation for architecture, or better said, to apply automation to reduce the cost of construction, to produce the houses that we've always seen. Yeah? So what changed? Perhaps nothing. And indeed, automation is actually a design problem. That's something that we're trying to work on, both in the Design Computation Lab at the Bartlett School of Architecture, which I co-direct with Molly Claypool, Jill Bretson, and Vicente Soler, and at our robotic manufacturing company, Nagami, who produce this furniture, as Xavier mentioned. Nagami is around the corner in Avila, in a land or in a place where land value is almost nothing. Yeah? So it's the perfect place to be creative and just focus all your energy and your funding in creating a factory to make things that matter for the world. We're using recycled plastic, and we're reducing the production chain to the very, very minimum. So from the computer, goes to the machine, we use only the material that we need. That's one of the premises of 3D printing, and more specifically, non-supported 3D printing. And we work both in efficiency and how we can print faster to reduce production costs, to get 3D printed furniture and products to the very many, and also in what kind of new natures we can produce and materialize with 3D printing. Each of our objects are trying to basically challenge everything that we preconceive about printing and try to push it forward to a new era. On the other hand, we also work on automated processes for scale-up versions of these material organizations. And what matters here is not that we use a robot or not. What matters is how we deal with design principles from the beginning, how we organize this material to be automated.
And it's all of this.
So this is a normal day at the Bartlett School of Architecture, at Design Computation Lab. There's a normal day in Avila around the corner. And even if we do products, we also work on design principles, on how we can get these pieces together, how a machine can not only produce the piece for another machine, but how can it assemble, as it was mentioned before, a larger object. How machines need to be readapt, which kind of animals, which kind of robots we need to produce different kind of architectures. Is the robot also a design problem? Is the robot linked to the piece that they assemble? And we work also in the flexibility of this kind of architecture thanks to automation. Can we actually define buildings that can be reconfigured? Can we reduce the number of pieces that are used in buildings so that we can disassemble, reassemble, and recycle those pieces again and again and again? How can we adapt to different necessities? I'm almost finished. Okay, I skipped this one. We're also thinking about social consequences of this. So what happens if flexibility is not only in construction, but also in the way we use the space? Yeah? What happens if Airbnb is not a static model, but actually we can share the space? If this space could be transformed over and over, if it could be used 24 hours when I'm not there, someone is using it. But someone wants to personalize it. You need to change things. How can you create an architecture that, thanks to automation, is responding to the 21st century? Okay, and just to finish, this is a video of Avila. It's a video I took. Yeah? Avila is around the corner again, 100 kilometers away. It has been exactly in this situation for the last 10 years. So as I mentioned, the crisis basically devastated all the small cities in Spain and in many other places in Europe. So land value is zero. It's all ready for something to happen there. So can we actually demonstrate the power of architecture and the power of design and construction when it's only about that and not about the speculation? Can we bring housing for the very many? That's the question that I would like to explore in these coming minutes. Thank you.
And well, thank you very much for that. Please take a seat. And the other two speakers are joining me on stage to, I hope, talk to each other about the presentations we've seen. But let me try to lace the conversation. It's meant to do that.
That's a break.
Yeah, it's an acoustic chair.
I should emphasize, it didn't break. It just shifted against a little step in the floor.
It does it. Yeah, don't worry. Doesn't break.
I'd like to talk about drivers of change. And I'm glad you mentioned the social towards the end of yours, Manuel. Because it was very much, I felt, watching you, Adrian, a sense of almost inevitable optimism about our use of robotics. Is it right to be optimistic? I mean, I personally think maybe the answer is yes, but there are some big challenges, societal, environmental, out there, political. Where do each of you see futures, and what's driving your work going forward?
People may be able to think of other examples, but I would contend that every technology that humanity has developed, except one, has been a net positive. Now, they all have disadvantages, of course, and we can all enumerate those, but they have more advantages than disadvantages. The one I think that's not in that class, as I say, some of you may be able to think of others, but I'm not sure, is explosives. We can do the things that we use explosives for peacefully, quarrying and so on, with other technologies. They just happen to be a cheap way of moving lots of earth quickly. But they have been a net negative. Every other technology is a net positive. So to answer your question, using induction, I would say the probability is high that it will be net positive.
No, you go first.
I think I'm going to respond to this question from my own experience, from an architect working construction and sometimes working with really advanced fabricators. The thing is that I always found is that I'm very positive about technology and how we can use technology, but sometimes we're not close enough to it. You know, architects would love to talk to the people that make the objects, right? Go and talk to them while they're designing, have a conversation with it. But I think what is as important is to go and have conversations with the operators of the machines and the robotics, because there is still a lot of craft in that. So I think that conversation we need to push more and more to really understand the technology more, and then we can really harvest it and kind of design better, I would say.
Because they're the people with the problems. They're the people who can define the problems.
What are the people with the solutions? And if we don't understand the technology to its fullest, we don't actually use it to its fullest.
Manuel.
Yeah, I mean, I'm obviously really positive about technology. I live with technology every day, but also because like all this criticism that is widely present, right, around technology, about like taking people's job and all that stuff. So, I mean, the same thing was the washing machine. Actually, the very first robot was a washing machine, yeah, and it liberated a whole generation to have to go to the river to wash the clothes. And they could actually occupy their time in other professions and they develop other skills. And that started then over years, Industrial Revolution. And these people started creating machines and so on, right? So I think technology is always empowering humanity to progress, right? And there's always a fear. But I think, again, you need to take it as a tool and acknowledge it as part of your progression, as part of the design problem, right? So I think in terms of automation or 3D printing or many of the topics that we are discussing today, we haven't really tackled them and we start to grasp them. And I think there's a lot of incredible things that will allow us to, create cheaper, faster, safer, and they are coming now. They should have come 10 years ago.
So what are the impediments that you see in each of your work to making the kind of, I imagine everyone wants to move quickly as possible, but what is it that slows you down? What is it that gets in the way?
Well, I think, like, for example, the chair that you are using right now, if you tell someone that is 3D printed, they don't trust it, they don't want to sit, right? And it doesn't break, yeah. It sounds like it doesn't break. I know. So I think mentality is difficult, right? The same thing is happening with the electric car, right? Like Tesla is having lots of problems in Spain because people don't believe on a different way of thinking.
So don't tell them it's 3D printed.
Yeah.
Just ask them to sit down. Don't tell them it's 3D printed.
Yes, exactly. Yeah. So that's actually
that's
how we are tackling this problem.
That's arguing against the point that Xavier was making, where he said we need to have more knowledge and more understanding of the technologies. What you're now saying is that we need to be ignorant of it in order to persuade people to adopt it. I paraphrase your argument, but that seemed to be what you were saying.
It was a provocation more than an argument.
Right,
I'm not sure I believe it, but what do you think?
Well, I was going to say, I'd just like to speak up in favor of ignorance. The most advanced technologies are ones that people don't need to understand to use. And let me give you an example, which is the oldest technology that we ever had, which is the technology of the use of living things. In other words, agriculture, our very first industry. All the food we eat is genetically engineered. It was genetically engineered by our ancestors, selectively breeding wheat, cows from aurochs, all that sort of thing. And they did that with no knowledge of DNA at all. They didn't need to understand how the technology worked in order to make the results of that technology change in the way they wanted to. Why? Because that technology, the technology of living things, is so powerful that that understanding wasn't actually needed in order to do something useful with it. Yeah. And so when we make a technology that is of comparable power, there is an argument that says that people can get use out of it without understanding the details of how it works.
Yeah.
So why do we have machine learning? Are you saying we should have machine ignorance? How
no, I'm not.
But in all seriousness, how do machines learn?
Well, they learn in the current paradigm. Of course, there's an artificial neural network which is modeled on the way that animals' brains work. How do they learn? They learn by being given a large number of examples, just as when we all learn to speak, we're given a large number of examples and gradually it sinks in by reinforcement from our parents and our teachers and so on. The machines do exactly the same. You have to reinforce them when they get the right answer and you have to punish them, not really, simply downgrade some numbers when they get the wrong answer. But I'm not saying when I say that everybody should be ignorant of everything. that was not my argument, but my argument was that a powerful technology doesn't need to be understood by everybody to be useful, which is not the same thing at all. And so clearly, some people need to understand things in detail in order to make subtle changes to them. We can make far more changes now we understand DNA, now we have CRISPR-Cas9, than we could make changes using selective breeding. And that is a detailed understanding. So some people need to understand things. The other thing we must remember is the most important aspect of understanding, which is that it's enjoyable. Human beings like to understand things, regardless of the utility of that understanding. And that is an enjoyable process in and of itself. And
I suspect we might hear more about enjoyment, aesthetics, artistry conscious reflection in the second half of this debate, but I'm keen to know where the artistry and maybe the craft fits into your work. Xavier, how do you reflect on what you've produced? Do you ask the machines to do it? Or how does the process work where you learn from what you're doing?
Well, I'm going to get back to the point I made. It's getting closer to technology, right? And I'll give an example on a project I worked at Foster & Partners. Was a Kulm Pavilion that was 3D milled out of wood, of CLT. And it was a conversation with the manufacturer and actually the person using the machine, and said, well, we can make it cheaper and faster if we just use one milling head, because we manufactured that head, and we were able to do just slightly change the geometry, and that meant that it was actually much easier to manufacture, right? But that knowledge I could never have as an architect. I need to go and sit next to that person using that machine, understanding it so closely. But going back to your point as well, as a user sometimes you don't need to know, right? Sometimes we fetishize a little bit too much. When I brought in 3D printing at Foster & Partners, the first 6 months, everybody who 3D printed something, the first thing they said, I've 3D printed it, right? After 6 months, I was very happy that everybody stopped saying that, that it was just a thing we did, and people just talked about design again. And that's what I'm looking forward to, that people stop talking about, although we need to know it, we'll stop talking about it. Yeah. And it's, again, what the object does. That's what I'm trying to do with the workshop this week here. Yeah? The first task we set the students was not thinking about 3D printing, was actually a small design task. So let's bring it back to that and use 3D printing and its opportunities to kind of get better designs out there.
And I think that's, that's totally the point, right? And that's what I was referring to when I mentioned that in the last 10 years, since the early 2000s, we've been fetishizing technology, right? Like we could, all of a sudden, we could materialize things that we couldn't imagine before. And we learn a lot from our failures. And, it's someone said once that machine learning is the best tool for human learning, yeah? And it's also, because it frees your mind to what is really important. And I think that's a process that we're learning ourselves, right? Like what we can automate and what we simply don't want, we can't. What kind of new avenues are there to explore now that we have other mechanisms that deal with the ones that we don't want? And I think that's an exciting moment for design, for architecture, for construction. And talking about tools will disappear. John Fraser did his master's thesis at the AA about creating a plotter, right? Do we talk about plotters today? Right? And the same thing will happen with robots, with printing, and we just need to acknowledge it. I'm
going to open it up to the room very, very shortly. But let me just ask another question while everyone thinks of their killer questions. That I have to ask, because at the end of last year's robotics debate, we started talking about the future of work. And I'd like to continue that conversation. What do we all do when the robots are doing it for us?
Okay. This question, as you can see, I'm horribly old. This question has been asked 3 times in my lifetime. The first was when I was a child, and when computers the size of this large room were coming in, people were saying, well, these are going to automate away everybody's jobs. Didn't happen. And the second time this question was asked was in the 1980s when the microprocessor was introduced, and people were saying, these are going to automate away everybody's jobs. And of course, it didn't happen. I suspect that the idea that AI and robotics are going to automate away people's jobs may be less significant than some people imagine now, simply by the history of the progress of that very idea, or rather lack of progress of that very idea. Human beings invent other things to do. We invent new professions around the technology. We invent jobs that, dare I say it, probably don't even need to be done, but still get paid for. And in fact, when you think
Such as?
well, all right, let me reduce it to essentials. There are only 3 things that human beings really, really need. And they are engineering, including, of course, architecture, engineering, medicine, and agriculture. To a certain extent, beyond that, everything else is a luxury. And so, if you're not working in those fields, well, no.
Sorry.
Well, we've got a sculptor coming up next, so
Well,
we'll see what he says about that.
I mean, but it goes back to what I was saying perhaps a few minutes ago about the enjoyment of knowledge for its own sake. I'm sure that our appreciation of art is very, very closely aligned to our appreciation of the acquisition of an idea that we didn't previously understand. I'm sure they're on a very close spectrum. And of course, anything that human beings value in the nature of capitalism becomes a commodity. And so Damien Hirst can charge rather a lot for a work of art, even though if we were all to examine the number of lives it saved, we'd have to come up with a small answer. Value doesn't just reside in utility.
Very good. Your thoughts about,
Yeah.
there's a lot of people going to leave this space today and think, gosh, what am I going to do next week?
So don't worry, universal basic income is coming. I do believe on it. But
Universal basic income.
Basic income.
Yeah.
Yeah. I mean,
I support
this
that.
of course, this is not a technical problem. It's not about robots. It's not about automation. It's a social problem. It's a political problem. And first of all, I don't think jobs will disappear. I think jobs will transform. But hopefully, we will be able to occupy our time in things that actually really matter, that really matter, and that are completely useless. Yeah, like art, for example. Creation. I want to automate my emails. That I really want to do. I want to automate bureaucracy.
Yep.
I think when you run a practice, the amount of time that you actually spend on running the practice or designing with it, on actually using what you enjoy and what you are good at, on really doing it, is very minimum and is less and less in the world we live in. So I really think automation will finally liberate us to come back to focus on what is good for evolving the world. That it has always been useless. Art has been useless, but it has been so fundamental for humanity. It needs to come back.
Thank you. Do you want to add anything, or shall I open it up to the floor?
Open it up, please, yeah.
We have time for a very quick question. I'm not going to turn to one of our eminent speakers because she's up next, but we have a hand up over here. I'll keep remembering to look over my shoulder as well. Yeah, third row.
I was wondering if you think that complexity of form, variability, number of prints, and cost are factors that are overlaps in the application of robotics, and if you would think of other factors.
That was a... yes, please.
Correct me if I'm wrong. You're asking about complexity of form,
Variability.
number of instances or repeats, and the
cost.
interaction of that with robotics and cost and so on.
Variability.
Yes,
yeah.
variability. Yes, it would be crazy to make this plastic cap with a robot because we need millions of them. And a robot is not an appropriate technology for making something for which we need a large number of copies. The technology for that is injection molding, and it will continue to be so because it uses considerably less energy than doing the same thing, for example, with a 3D printer. It's much, much faster, and for that large number, it's cheaper. But if you want, for example, a replacement arm for somebody who's lost, due to amputation, their hand, and that has to fit their unique form of their forearm, which remains, then 3D printing is an ideal technology for that because it has to be custom shaped. And we can't do that with mass production technologies. So these technologies find their application according to the number of items that we want, whether it's 1, whether it's 17, or whether it's 17 million. And of course, the interesting thing about architecture is that you can say that we want many copies of the same house, perhaps, or we want just one building, but it's always a comparatively small number compared to that sort of thing.
Yeah.
So
I think to add to that, I think it's not, like 3D printing specifically, is not a replacement for like injection molding and so on. It's a new industry that is creating a new market, and is empowering people to do something they couldn't before. Like, for example, all these pieces that you see, I couldn't have created them if I had to invest in molds and injection molding machine, and I think that's allowing creators to really immediately jump into their ideas and materialize them. So I think the conversation about variability, the conversation about formal complexity, we are kind of getting over that and really thinking about new modes of creation and product development and so on, that is totally creating a new market and a new industry. And as you mentioned, if you want to do millions of them, probably it's not worth it. But if I want to do millions of them, I have to do millions of them. I have to do always the same again and again and again. And probably, I get tired very quickly. So in 3 years, I want to change that model and create something else. And this is a tool for us.
Excellent. At that point, I want to say thank you to Manuel, to Xavier, to Adrian for joining us on stage, being part of this discussion. And as I let them leave the stage, I will bring shortly our next group, one by one, to the stage. Perhaps pointing out, I don't know if everyone else felt the same from Xavier's video. We saw the robot put the butter on the toast, but we never saw it spread it. And were you all like me, expecting it to go off in that direction? So there's something we need to work on. Okay. Part two. Let's see how the issues vary. I'm going to invite first Anna Dyson to join us. Anna holds the Heinz Professorship at Yale, which, among other things, connects her between two interesting worlds, the world of the forest and the world of the city, if I could put it as simply as a chair has the privilege of doing. And Anna is the first of our three next speakers, and the stage is hers.
Okay.
There you go.
Let's wait till they... Rural to urban migration is accelerating at an exponential rate. Instead of looking at this as a catastrophe, we could look at this as a tremendous opportunity. This pavilion itself was 3D printed with post-waste bamboo and bound with biobinders. And so it's a test to see how far we can go using solar energy and clean energy means to print buildings with waste products. We evolved to coexist with natural systems, and so we really need to find solutions to replace steel and concrete in the built environment so that we don't have to suffocate our natural environments with concrete and steel. Another great thing about these biological materials is that they sequester carbon throughout their lifetime. So they're basically doing a tremendous amount to reduce carbon emissions towards climate change effects. First of all, thank you so much for having me here. It's a tremendous honor. I'd like to dedicate my next 3 minutes to Professor Fernandez Galeano on behalf of our students at C in New Haven and my former students at Case in New York City. He has probably had more of an impact on our graduate students in built ecologies. They're design students that come from many different fields, biology, many aspects of engineering, architecture, sculpture, design, etc. And we feel that if we have even a course in technology or critical theory history without one of his readings, it's really seriously missing something for us. So thank you for what you've done for us. So it is true that was my voice, and when I was asked to do 5 minutes, I decided I'm going to show the 2-minute clip from the UN. And I have to take responsibility for what I said there, but it is actually 2 minutes out of a 90-minute interview. And I love to have that feedback when one gets edited that way, because at the end of the day, the UN environment, our partners in Habitat and Environment, took out the vast majority of the interview that was sort of an obsessive detail about the what and the how of what we're doing, and really boiled it mostly down to the why. And I think this is a great lesson for us, because at the end of the day, what my professors always encouraged us to remember to ask, who cares? And what do they care about? And why do they care about it? And maybe also very important for a designer, what do you care about? Is it still relevant? Does it remain relevant? In other words, is it so inevitable what we do? What our collaborators in East Africa care a lot about is to leapfrog over what they would call the dumb 20th century infrastructure that we have saddled ourselves with. We use these terms a lot, abiotic infrastructure, or dare I say, is our infrastructure antibiotic? Our work really is mostly at the nexus between material systems, energy systems, and water systems. And so, for example, we're interested in 3D printing from the standpoint of how it might interface with other types of conditions. In this particular case, for example, our collaborator from University of Nairobi is sitting on a solid-state heating and cooling seat, where basically we're very tightly coupling energy that we are collecting from the environment. I'm not sure if we can call it endosomatic energy, but it is basically ambient energy flow that we tightly couple into and transform into some form that might be usable at the time that we need it. In this slide, we're showing actually a very, very, in a sense, low-tech, high-tech process. Directly from coconut coir, a very powerful and beautiful material. We have massive, massive waste streams of coconut coir throughout the oceans and landfills. It's an increasingly high value-added product for cosmetics and oils and all sorts of uses. But it's notoriously difficult to know what to do with these waste streams. So what we are really focusing on is this idea of circular material economy through growing systems, systems we already grow that already have a tremendous amount of intelligence in them, and how might we harness that intelligence and reconstitute them. In that last case, we're literally talking about panels that have a very, very high strength and can be pressed from a hydraulic press that is in the back of most trucks and cars in East Africa. We're also experimenting with how distributed can we go. Can these presses or 3D printers be located on the sides of farms? What is that relationship between labor and the delivery to site? In our context right now, having a lot of people on site is a tremendous value. So we have to be aware of that. But as Manuel has pointed out as well, we're not using machines necessarily to take people out of the picture or to reduce, let's say, a haptic condition or connection to a site. Maybe that haptic connection will be stronger if we're more intentional about it. So those are some of the questions that we ask in these experiments. These are collaborations. In this particular case, we had collaborations across multiple universities in East Africa, University of Uganda, University of Rwanda, and University of Nairobi, and Kenyatta University were all participating. Multiple disciplines, of course, too. I just want to say, relative to the price point as well, there's been a lot of discussion about trying to make 3D printing faster, create less volume, et cetera. And these are values that are really coming, once again, from mechanistic industrial culture, but agricultural growing scales have a very, very different pace in volume and time, of course. And so how we work with them in conjunction. There are, as part of this pavilion, actually, there are Strawtech panels that are made out of post-rice byproduct that are pressed very simply and are at roughly, I would say, probably just under $10 per 10 euros, it's more dollars, 10 euros per square meter. So we're talking about very, very low cost processes in some cases for structural materials. And most of all, what I'd like to just leave behind, which is our interest is in probiotic environments, so-called the sort of adding of net biodiversity into an urban or building environment. And one of the most important things I believe in the future of 3D printing, as an example, would be that we start to experiment with a relationship between biotic processes, let's say, that are informational, robotic processes, and biotic processes. So really the intelligence that we have in the biotic processes, the amount of geometry and a tremendous value that goes all the way down in scales that can actually be harnessed in many types of combinatorial synthetic processes, low heat, low added processes that actually could be recombinated with 3D printing is where I think the future of harnessing this technology will come from, because we, just like living systems, we really need different geometries at different scales, and we need lots of different diversity and heterogeneity throughout our systems. Thank you.
That was great. Thank you. Thanks so much, Anna. Our next speaker is Phillip Beasley, who is a professor, among other things, but he said, just call me a sculptor in his introduction. I'll let him say a lot more about his work as I hand this baton to him. All yours.
Thank you, Timothy. I'm going to make some comments that speak about standing on the ground and the world and responding. I'll offer some new craft, and I'll try to end with an amateur's view of some new physics that might give optimism. I come from a place of solidity and strength where nature is perhaps eternal, and yet what can I do when my land, my goodness me, has dissolved and is almost unspeakably fragile? How can we respond as designers and makers? It would be profoundly important to know that we can make almost zero trace encapsulations and limit our footprints. And yet, I have a tremendous worry about those kinds of wall making. Perhaps the sense of a sphere is a sense of beauty. It's been taught that way to us for 2,500 years, and yet I think it also is a machine for resisting the world. There can be no less reaction face than a sphere, for example, in mathematics. And so I think that along with its extraordinary elegance and beauty, such a kind of paradigm for form making can also be thought of as a source of evil, for ballistics, for death, for boundary making that resists. I'd much rather think about material as having a radically large reaction face, like a snowflake, like something which is unapologetically fragile, which can find a reason to create fertility in the world. This is a rather optimistic vision. I think we have some crafts that can justify multiple boundaries and octaves where we can feel our impacts and start to create a kind of pluripotent space. And I'll try to justify that with some craft. For example, making with multiple vaults. These are images from my own studio. Working with resilience, in which multiple layers are held above and below, gentle pumping imparted through, bundling, basket making. The sense of not necessarily consolidating into crystalline orientations, but instead looking for quasi-periodic geometries that constantly cross-link each other and create tremendous fertility, such as the prime geometry that you can see here in the Penrose tessellation. And working at the edges of our perception too, not simply working for clarity, but also taking shadows so very seriously as the edges of our perception, as a kind of a festival of possibility. When I think of those kind of qualities, then I layer in as well the sense of a distributed robotics, not the kind of robotics that enables me to do my bidding and to shape the environment primarily, but rather the kind of empathy and resonance of trembling kind of qualities of the world itself resounding with me. And that in turn can result into some design paradigms that have a festival of precarity itself, of trying to find the kind of manipulations in which bifurcation is extremely uncertain. And that kind of reactivity is what we search for. That results in turn, into kind of a trembling, we can cut the sound by the way, and something of a joyful kind of reaction, which in turn is deeply lined with manifolds of new chemistries, protocells, prototype cells, searching for a way that architecture can turn into a reef that can be deeply lined with new liquid metabolisms. This results in some practical vehicles which can in part be quite strong, shells, at the same time being deliberately weak and compliant, stretching out, membranes that flux and move with the atmosphere, together with some softwares that search out and that work with behaviors. For example, the kind of topologies that we're now working with are deep meshworks in which the associations between individual microprocessor nodes are quite flexible and malleable. They work now not simply with goal seeking or reward setting, but also with functions of curiosity, that is, rewarding the new, the non-recognized, as deliberately disruptive qualities in order to search and continually refresh the environment. Now, this kind of behavior is disruptive when it's held alone, but when it's worked in combination with predetermined scripts and predetermined behaviors, there can be a tremendously playful and coherent way of working with the world. And you can just see a couple of examples of that behavior in which this machine is hesitantly exploring me and then eventually getting rather bored and going still. But just little spasmodic gestures there you can see. A paradigm then that I've spoken of firmitas, of working with the solid world, is something that I think can be changed into another paradigm of deliberately designing for precarity. Not a precarity of the uncertain, of the ground being pulled out from under your feet, but rather the festival of rolling down a hill and deliberately making yourself dizzy. Perhaps this contests a fundamental law of physics, the second law of thermodynamics. If we agree that things start with order and then inevitably turn to dust, then perhaps resistance and holding on and conserving is absolutely necessary. And yet, new physicists seem to be saying that dissipative forms, the kind of intermediate forms under the open systems of the world, are absolutely tenacious. The rippling of sands, the continual swell of the ocean, and new physicists such as Jeremy England, building on Ilya Prigogine, even say that life itself creates entropy and creates a maximum of extraordinary refreshing kind of instability. You can see a model of that kind of quality that I think that we can actually dwell in this model of quasi-geostrophic turbulence. Sorry for that composite word, but it means a state in which multiple forces are very nearly balanced, and so they can tip just one way or the other in a very, very gentle, refreshing sense. And so what I want to offer is a couple of new paradigms. Instead of firmitas, the fundament of architecture, I want to offer precarity. And instead of an older generation of entropy, I hope that pluripotency, the sense of multiple possibilities, could be a paradigm for architecture. I've started with a sense of solid ground, and I've moved to a rather uncertain sense, but I hope that this is an optimistic one. Thank you.
Wonderful, thank you. Quasi-geostrophic turbulence is a phrase I shall repeat again and again. Thank you so much. Our last speaker, before all the speakers, all the three speakers join me on stage, is Claudia Pasquero. Claudia is a professor at the Bartlett at UCL, and she's the director and co-founder of Robotics Studio, based in London, I believe, but let's hear some more. Claudia, all yours.
Thanks for inviting me. For me, architecture is polycephalum. Polycephalum in Latin means multi-headed. But also polycephalum, or Physarum polycephalum, is the name of this mold. It's a unicellular organism. It's a slow simulation. I work with since 5 years now. It takes 2 weeks to calculate minimal path. The slime mold is considered by scientists the next biological computer, or a form of bioartificial intelligence, because it's able, despite being a unicellular organism, is able to optimize resources and distribution in a way that is similar to what we need to do in cities, but does it through collective intelligence and distributed spatial memory. What interests me, though, is not only how clever the slime mold is, but is the fact that in the slime mold, the ecology of the system is embedded in the aesthetic of its pattern. This is something that I investigate in a trans-scalar manner in my academic work, looking, for example, with Innsbruck University at glaciers. Glaciers are one of the symbols of climate change, but the planet we inhabit changes all the time. We can't stop change. But through satellite, we have a collaboration with the European Space Agency. We can monitor the changes, the material transformation. We can read them. And maybe while looking at crystallization, trying to understand how can we transform glacier. Can we instill a positive dynamic? We cannot stop change, but we can read it and instill different form of dynamic. This was an experimentation used in 3D printing as a way of influence crystallization. At the moment, the way glaciers are preserved is by covering them with a ginormous blanket. That is the latest technology in preserving glaciers. Can we imagine three-dimensional blankets that are form of architecture, that are also able to interact with the glacier itself, but they are not responding to a single use. They are polycephalum. They respond to multiple use. They are resilient form of architecture. So we talk about robotics, but you will see no robot in my presentation, because for me the machinic system is the relationship between artificial form of intelligence, biological form of intelligence, and human, somehow in Latour terms. With the student at the Bartlett instead, I look at the micro scale and how we can develop new form of material that have impact on the city. Spider silk is one of the, am I over 4 minutes already? No.
You have.
Okay, perfect.
At least 3 minutes.
Okay, cool. So spider silk is in comparative density as resilient as Kevlar, and is biocompatible. So there is a lot of investment in spider silk, but on the other hand, when we are in architecture, bacteria and insects are not part of the aesthetic that we investigate. Somehow we still inherited from modernity a sanitized view of beauty. The white surface is the beautiful one. Can we reverse this paradigm and try to understand how can we interact with innovation in biotechnology as well as artificial intelligence? We learn from scientists we can reprogram spider behavior. This is an Asian fawn tarantula through 3D printing substratum, through spatial articulation. So in this case, the student investigate the aesthetic, the merging aesthetic of spider web through reprogramming it spatially in this component of a potential futuristic facade, which is called xenoderma, alien skin. This was developed, and then we developed a prototype that was presented at the Centre Pompidou. Of course, it will take some time before spider web will be integrated into building, but we can also think about using the spider web in a different way. The protein of the spider web can be reprogrammed and 3D printed. So we can imagine buildings that behave because we program their behavior. So the one on that side is a 3D printed protein, while this is printed in plastic. But we can imagine that in the future we can expand in that. And then I conclude with a research, and how I bring this in my practice. So it's now 10 years that I work with cyanobacteria, are some of the most resilient organisms on the planet. This is the Baltic Sea. The little line that you see is a boat, and this is the blooming of algae. At the same time, because algae are very resilient, they are able to produce oxygen at a very high rate. They are able to be used as a form of energy as well as protein. So we investigate with the practice as a form of sculpture. This is the super tree. Is speculate on a column that integrates as well production of food and energy. And it consumes CO2 at a rate that is 25 times the one of a large tree. We also look at architectural system. This is the first built photosynthetic architecture. It's the biotech hut. It's 180 square meters, produce an amount of oxygen which is comparable to the one of a small forest or 32 trees, and an amount of protein that is equivalent to the breeding of 8 cows. It's self-sufficient in terms of energy. I'm saying that not to justify the design, but to discuss the fact that the design is embedded in the number are embedded in the materiality. We propose a shift from architecture as the machine for living to the living machine. So the biotech hut integrate also bioluminescent bacteria, are very difficult to work with, so maybe we don't integrate that tomorrow. And there is a scientist in residence that demonstrates what you can actually do with microalgae, as well as a sculptural element with which people can interact and provide CO2 themselves. In the main larger structure, the CO2 comes directly from the exhaust of the building, while in the sculpture, the visitors are invited to provide CO2 themselves. This is me. Okay. We went on, and now we will conclude. So we develop also a component for facade, and we look into evolving from microalgae into liquid into biogel, and that gave us the idea to start and think, how can we articulate further this relationship in which architecture becomes a medium between human life and non-human one. So one of the latest research look into 3D printing, both the substratum of grow microalgae and the microalgae themselves. This is a sculpture, but can also be imagined as a component of a facade. Was originally developed for the Centre Pompidou, now is in Vienna and soon will go to Tokyo. Here is my partner inoculating the microalgae, but you can think in the future with a double nozzle, you could print both the biological part and the non-biological one. This is how it was in the exhibition, and the morphology was, well, I'm not going to go into that because I'm too... And that was simulating a form of cyber gardening, so how you interact with the structure itself. We don't imagine this prototype as singular, but as distributed in the city. So we are working with the Seto City, we have a project with UN, where we look at how these become form of biotic infrastructure, a form of textile on city. This is Stalin, but I don't go on this. This is all from polycephalum architecture.
You can take a seat. Thank you, Claudia. I gave Claudia a bonus minute because the clock at the back was fighting against her, the machine's fighting back. As our guests, speakers, take their seats, I'll just remind everyone to think of questions that you might like to share. I also had the privilege of sitting between the speakers during each of those presentations, and I could hear an almost visceral response of delight from both of you to each of you. And I'm sure there's something that you might want to share between you by way of conversation, if I could encourage that. Can I start with a question about you're using technologies that I think I might have seen before in ways that I haven't. Do we have all the technology we now need, or do we still need more? Anna.
Me first. I would say that technology is this ever-evolving thing.
Was it Al Gore who said,
yeah, that's right.
We've got all the technologies, we just need to use them?
Well, unfortunately, I would have to disagree with that. I think that we need to make major pushes, major investment as societies towards pushing all aspects of and that also includes human systems, which are the collective hive mind pool that we produce in socioeconomics, et cetera. Very important to understand how deploy technology in very different ways. So I don't think we're there yet, definitely not. If we were, it wouldn't be so hard. I think that I don't believe really in forcing these things. I think when solutions are right, they will be adopted. And therefore, I think that there's a lot that we don't have, and that is not convincing yet enough to people. So I would say we're in process, always. Yeah.
Sometimes when I am able to work with new craft, I feel thrilled with the ability to touch things that we only dreamed of. At other times, I feel so very sad about the reduction and the stripping and the polarization that still happens. I mean, for all of a love of filamentary deposition, for example, the kind of the very hesitant sense of the deep material states and the multiple vectors of forces that preceded it in some analog processes are lost, or at least are held in crisis. And I think that we are still far from some basic understanding of how to make things that can impart fertility and indeed come alive. The sense that in new physics that a theory of entropy or even potential has been continually flipping on its head, even today, into the sense of perhaps the fundamental precepts are still wrong about how we understand potential, should be evidence that we're far, far from being able to work responsibly. Right now...
But do we need more technology to do that, or do we need more people like you who are applying technologies to manifest new
I don't think that we need more sorcerer's apprentices like Mickey avoiding the chores of swapping the stairs in Fantasia, opening the magician's catalog and using it irresponsibly. I think that's what I do. I do think that we need some new technology for working with the viscous and intermediate states and the slower states that are so very poorly understood. And I think there's a dream of still working with being able to print sensitively.
Well, I think I said before, or some Greek philosophers said a long time ago, nothing changed but change. So as human beings, I think we will always invent something new. But for me, we need a shift in the way we invent or we work with technology. So we come from probably 200 years very driven positivist thinking, in my opinion. And I would like to try and understand that we conceive technology from without, not from within, a problem-solving framework, which doesn't mean I don't want to solve problem, but I just think that aesthetic and other type of discipline, like design, could have a saying in understanding how we evolve, which could be much more political and ecologically connected than it is at the moment. Because as human beings, we are able to understand reality logically and metalogically. So the arts are part of our metalogical understanding of reality, and they are vital to discuss the current political, ecological issues. So architecture has got a role in there, not just in making something prettier, but really in proposing a different type of approach. So we will keep inventing, but I think for me, we need to shift the way we invent. Somehow shift the technology to the technique, if we want to go.
From the technology to the technique.
Yeah.
To the technique. And I mean, that was something I saw, I think in each of your presentations, that from you're working with spiders, you know, they're part of your design team,
yes,
in a way, production team, whatever. They're sort of creating things that structures and forms that you hadn't designed.
Yeah.
They were emergent. From you're moving from the sphere of, or the singular form of the raindrop or whatever it was, or the bullet, to something like a grid and a net, and to you working in resource, I hesitate to say resource light, but energy light, perhaps, situations to try and make the best of the available resources. These are not conventional architectural applications where we're dealing with great levels of resource, often great budget, and often singular ideas.
Yeah, in some ways, in our context, we would not see it. It's only a terrain of scarcity from the standpoint of conventional systems. But it's not necessarily, in fact, actually, the constraints are tremendous opportunities. So, for instance, we work a lot with the UN on refugee or sort of transitional housing. And in that case, where we're not allowed by host countries to touch the ground, to go into the infrastructure, but we have populations on average living 18 years in these environments, many more in certain areas like Palestine. So one can grow up their whole life in a provisional setting. The opportunity is to really, in a sense, derive agency from another type of order or another relationship with the surroundings. And it doesn't absolve states from having to do something. So we don't want it to sound like it's an either or,
yep.
Bottom up, top down sort of dichotomy, not at all. But just to say that it's not necessarily scarce if one looks at it in a different way.
But these are non-conventional applications.
It's not
That's what I think I'm trying to say.
Yeah.
And I saw cities in your work, Phillip, and certainly you're working in cities at scale. I saw grids, and I saw these incredible. I think the grid of the city is the greatest product of humanity. The fact that we've created these lattice works that encourage a word I was wondering about whether it could be added to your list, which was serendipity, which is, the unknown, the unexpected, which seems to be part of these unplanned, sometimes, interactions that are possible. But I suggest each of your technological applications. Is serendipity an important part of your work?
I feel rather ambivalent about serendipity. I mean, on one hand, when I think of the extraordinary enabling matrices that you've showed us, I think of small economies giving a really satisfying substance. What I wrestle with is understanding how major changes across the world might be enacted in time to avert catastrophe, at the same time as the necessary kind of increments. And I guess when I think of Buckminster Fuller's extraordinary kind of project of the geoscope of traversing the entire world in order to enact good, the world games of governing and responsibly kind of adjusting things, I'm not sure how to reconcile that vision with Julian Assange's assertion that world order is evil, and that it aggressively needs to be undermined, and that in fact those imperial forces are so strong that actually we can be somehow perniciously subversive and as an act of a contribution. I don't know how to reconcile those things. So I'm very hesitant to agree that serendipity can be used in a time of war.
I'm going to open up to the floor. We have 5 minutes or so left to run. Time flies. And ask if there are any contributions, questions, especially for the people I never get to see behind me, that they would like to,
Hello.
To bring to our speakers. Who's got a question?
And you.
Oh, yes.
You're all waving now, and I can't tell whether you've got a question or you're just waving. If you've got a question.
There is a question there, I think.
Thank you. Yes, sir.
Hi, everyone. I would just like to point out that there is a big difference between the first debate and the second debate, in the sense of we're talking about difference between understanding the technology. On the other side, we also had the impression that technology doesn't have to be necessarily understood, but just to understand that there is a useful application of it, which I think there is also a danger of creating users in this type of economy which we live in and just continue with constant growth, which doesn't really help with the environmental footprint. On the other hand, also, I wanted to point out that previous debate also noted that you talked about Tesla and Elon Musk company, which he's very against artificial technology being misused, and this is what Mr. Phillips is actually talking about, that he doesn't really believe that there is a possibility of the technology being used in the negative essence. But then again, you do have people, for example, in US, when the 3D printing actually came out for the first time, was actually when we talked about creating your own weapons and house weapons as well. So I'm lacking here in these two debates, especially talk about the ethics of robotics, as well as the fear within the economy and the development of the economy. So how could you actually maybe comment on that? Thank you.
Thank you.
Ethics, it's a very short word.
Well, actually, I'm really interested in some of the things that my colleagues said about that. I mean, I do feel that ethics are inseparable from aesthetics, for example, and I wonder whether or not just having more of a discussion of actual sort of, you know, the aesthetics of what we're doing and where they come from, why we're attracted to them, et cetera. I mean, why are we obsessed, for example, with a lot of these sort of self-replicating machines, if you will? And I think that they have a tremendous power for us. And I think you bring up some really important points of sort of maybe, if I could paraphrase, technology for technology's sake, or when technology is unconscious, or if it's not part of a more critical discourse. Prior to this panel, we were discussing this, is like which technologies might have been inherently a net negative for society, and my colleague from the first panel, Adrian, had mentioned explosives as being one of the obvious ones that maybe we didn't really need at the end of the day to do some of the things that we do, even mining or other things could have been done in different ways. So, and did we have to mine in the first place? I would probably add to that. I don't think technologies are neutral. So maybe if that's what you're asking us, I think there is an inherent politics in the way that we make things, an inherent ethics. I think politics, all artifacts have politics. And is there something inherent, for example, to 3D printing? I think there is, and I have to admit that I'm struggling with it myself as to where it is. So I can't really answer you either way, but I agree with you, essentially, if that's maybe, it's not neutral, and I think we need to really dig deep to ask, what is it doing, how is it doing, and why are we doing it, once again. For the moment, we think that we're doing this because we're interested in sort of building, in a sense, in more complex, more embedded ways. And we feel like it's a bit of a stepping stone, if you will. So I think that in and of itself, that's an instrumental attitude, and one might be critical of it, and maybe I kind of am. So sorry to say that, but.
I think it's a very important question that you're asking about ethics, and maybe building off of what you said. If we are to practice ethics in the gravitas that we are affecting the world, then it seems to me that the generation that we've come from has sometimes satisfied itself with power analysis and a rather righteous sense of the interrogation of things, which simply does not make for the kind of involvement, the kind of robust kind of involvement that would allow us to find very, very fine-tuned moral judgments. And I would rather practice ethics in the state of precarity in which ambivalence is a very positive term, understanding both sides of a situation. And the evidence of that, I think, in architecture school might be in the practice of irony and a slightly subversive quality alongside gravitas. And it makes me think, for example, of the tradition of Gordon Pask, in which this extraordinary kind of explosion of power still allowed something of play to be practiced, trying to tip right on the edge of the capacity to do good, but also to be dizzy about it.
Is this something in your practice, Claudia, or in your students' practice that is a consideration, the ethics of production?
Well, the ethic of production, well, if we judge robots from the ethic of where they come from, then cybernetic is a war machine, so we're all doomed, I guess. But, but then cybernetic is also discussed in anthropological term communication, so a communication between different forms of intelligence. So, you know, it's not black and white. But for me, the issue is how you really, as I said before, interweave ethic with aesthetics. So how do you stop using technology as a gadget, but you distribute it in a system that is more complex, that you can judge logically, but you need to judge materially by interacting with it. So you can learn about it, you can acquire knowledge by reading about it, but you can also acquire knowledge by interacting with the pattern of production. And that for me is crucial. Yeah, we are very far from there because we are in a society of closed product. But for me is, if we open the product and we expose the process, then we may be in a cognitive term, in a totally different society that could potentially trigger self-organization and collective intelligence from local interaction. But then I don't know if that will ever happen.
Claudia, that reminds me of a series of mongrel-like examples that we saw in early 3D printing of houses. I mean, they're amongst us today when we are somehow vainly trying to produce a vernacular shape with this new enablement. And I was taught the term skeuomorph, which means working with new materials, but without somehow tumbling in reference and making sometimes kitsch in the sense of emulating other things. Perhaps there's something of a state which is tremendously helpful in that, though.
I think there's something about copying reproduction and the little mistakes and variations that occurred during that process that would perhaps link us back to some of the ideas of evolution that we've been able to talk about during this week.
Well,
but I'm going to say, sadly, time is against us. I'm sorry, everyone, but we're on a schedule. We've got a great week ahead and a lot more to do. But let me just say thank you to everyone for coming today, for being online, for watching this in the future. Let me thank again the Rolex Institute for its support over many years now on the subject of robotics, which is not settled. It is moving. Last year, I discovered 3 kinds of robot in my summary: the robot that does the jobs that we already do, the second robot that does the jobs we could never do, and the third kind of robot that makes us cleverer and more inspired as creators. This year, my little summary is that perhaps the first half was about, and forgive me, the makers. The second half was about, forgive me, the users. But there is a third piece here that connects both, and I think takes this then onwards, which is the ethics of practice. And perhaps that's something which, if we gather again in the future, we might be able to talk about further. Just before your rapturous applause, to let you know what's about to happen, especially for our speakers and guests. The speakers are all going to join me on stage for a very quick photograph, so be prepared to do so. And let's say thank you to the Norman Foster Foundation, to Lord and Lady Foster, who are here with us today, to the Rolex Institute, and especially to the speakers who have inspired me and you very much indeed. Thank you all. Thank you. So,